So, hello again, everyone. We're gonna continue with our fourth talk for today. Then we will have a quick lunch break, or like small break, with Nicolas Bevacqua, and he will talk to you about Browserify.
Hi, everyone. So my talk is Browserify all the things. I'm Nico. I posted the slides on Twitter if you want to follow along in your notebooks. I'm also on GitHub, and I have a blog at bonifu.com. I just finished writing a book called JavaScript Application Design. It focuses mostly on quality, developing modular applications, processes, and it comes with a bunch of code samples that you can look up. Those are open source, so you can look them up on GitHub too. And here's a discount code that you can use if you're interested. And you can also come talk to me after if you're into the book. I can tell you more about it. So modules. Modules are a great thing, right? I think we can all agree on that. So there are a few different ways of getting modules in the browser. The most common way is using closures. Not that kind, but close. So closures, we are pretty much everyone is here, I guess, is familiar with this kind of closure. It's basically a self-invoking function expression. They go by many names, but that's one of them. And everything that's in the closure is local to that scope, right? So you don't link to the global object, blah, blah, blah. But it doesn't get you very far. You have to develop modularity on your own. And if you want to communicate with some other modules, you need to use the window object, right? So if you want to declare a math module, you'll probably use a closure, declare your private functions and whatnot, and expose something on the window object. And then you can use it somewhere else, right? But you get a handcrafted dependency graph, which sounds really great, but it's not, because it looks pretty much like that, and you have to put it together by yourself, right? So it's making a face too. It's not a pretty sight. So as a recap, closures abuse global variables by having you expose your modules on the global object. They're fine for tiny projects. If you have to work on a weekend hack or something like that, you could use closures and that would be fine. The issue is that modularity is up to you, and you have to figure out whether to use the window object to share modules, references to modules between each other, or something else, right? And then there's dependency management, which is a mess, because you have to add a script tag for each dependency and figure out the right order so that those dependencies don't crash the whole application. So you can definitely do better than that. So that's my talk. Thank you very much. Actually, I'm going to show you 3 different ways you can attain modularity while fixing the dependency management issue. The first one is AMD modules. Not that kind, but close enough. They look more like that, which is a lot of documentation, right? Just to get started, use with jQuery, Node, Dojo, optimization API, why, requirements. Okay, anyways, yay, you got dependencies, right? So require.js basically has a public API that uses a closure as well to wrap your modules, and you return a value that could be a function or an object. I'm not sure about value types, but whatever. And that's your module, right? And you could pass in an array of things your module depends upon. So here I'm defining the math module, and if I want to consume it, I'll use that as a dependency. and that will get injected into my module, which is kind of nice because it also allows me to do unit testing and that kind of stuff really, really easily. So you get modularity, but at what cost, right? Because the main issue that I find with requires.js is that you need to do very specific things for each different corner case that there is. The good thing is that it resolves dependency graphs for you, since you are already giving it all the information that it needs. Like my main module needs to fetch the math module, and the math module doesn't need to fetch anything else, so it'll resolve. Then I go back to the main module. Okay, math, I have that, inject it, good, it's working. And it's able to figure all of that without you having to stack script tags like a deck of cards. The issue is that it lacks a straightforward API. It has a zillion ways of doing everything, and it's really convoluted. The other issue that I think is an important one is that AMD modules tend to suggest that during development you use the asynchronous loader, whereas in production you are supposed to bundle everything together into a module and use that. And the problem with that is that it changes drastically the way the application behaves one way or the other. And why would you have, as one of your greatest features, the asynchronous loader that's able to do everything compile free and whatnot, and then on the other hand, for production, you pretty much need the build step? It's weird. And the other issue, of course, is that there is just so much clutter, and you need to do like a lot of ugly stuff to get it to work. And the other issue that's kind of been resolved recently is that if you need to work with libraries that don't really use AMD or UMD or some module system, it's really hard getting it to work with AMD. You might even have to try and convince that library's authors to implement something in order for it to work with AMD, which is crazy. But that's how it usually went. Then there's ES6 modules. And if you saw Axel's talk earlier, you probably heard a bit about this. Luckily, I just will show you the API. So they look like that, right? So you do export default, your API, that's it. Every file is a module. And if you need to import something else, use the import statement, which is kind of like bar for modules. So you do import math from math, math being the relative path to the other module, and you can use it. So that's like a variable declaration for another module. And the reason why you have to use import and not bar is mostly because of backward compatibility with parsers. So ES6 modules are kind of the way forward in that they're probably going to be used in the future by pretty much everyone, hopefully. But to use it today, you need to add a transpilation step that's able to compile those ES6 modules down to ES5, ES3, something that runs on browsers that are in use today. The other issue is that it's hard to interact with CJS modules or CommonJS modules. And this is an issue because if you're trying to go full ES6, you really can't, because they aren't really popular yet, right? And this means that you'll have to either use CJS or AMD modules to complement those. And that's where it gets tricky, because ES6 modules aren't really generally available yet. They're not popular, which means that besides Angular, no one uses them, really. And even in the case of Angular, they basically have their source code in ES6, but they have ES5 distributions as well. But let's stay positive. We still have Browserify to save the day, today at least. So CommonJS modules. CommonJS is the module system used in Node.js. How many of you have actually used Node.js? Okay, awesome. So with Browserify, you're able to take CommonJS modules and bring those to the browser. And the other cool side to CommonJS modules is that you have npm, which is a package manager that's filled with CommonJS modules. And these aren't just Node modules. They are not just meant for the server. There are many CommonJS modules written for the client as well as for Node and everywhere in between, like code sharing between the server and the browser, or even some modules that are able to swap implementations between the server and the browser where it makes sense. Like if you have a module for Node that uses the file system, for the browser you can write something that's swapping out the file system parts with something that uses local storage, for instance, for persistence. So CommonJS looks a lot like ES6 modules. You have a module exports API, and you assign your public API to that. Every file is a module too. And then you have the require method, which is also local to every module. And you can use bar statements, and you pass in the relative path to the module, and you are able to use it. The math variable will be assigned the value of module exports in the R module. So CommonJS modules have a similar API to that of ES6. They take advantage of npm by being able to use virtually every Node module out there, although some may not make a lot of sense. But you have Browserify for the client side. And this is the really cool part, as we'll see later on. So Browserify comes as a command line tool, and it has a programmatic API. And there's also the usual gulp, although I think with gulp you're meant to use Browserify programmatically. And there's the grunt, broccoli, etc. plugins. So if we Browserify main.js from the earlier slide, we'll get back a bundle. That's the code that you can run on the browser and have it behave exactly like the CommonJS we saw earlier. So you'll get something like that, right? That looks like a lot of gibberish, but if you look closely, you'll see that you actually have your modules pretty much as you wrote them, wrapped in a lot of ugly stuff. So if you Browserify main.js into an R file, or you pipe it to an R file, you're able to add that to your browser, and it'll actually print 7 like it's supposed to. So let's pause on the Browserify bits for a second. Discuss quality and why it's great for everyone. And the point here is that every module that you write should be simple, have a single, very well-defined use case. And here's an example, insertRule. This is a module that, this is a module that is allowed to insert a CSS rule into your pages. And the idea here is that you have a flexible API while providing consistent results. And this really means that in the case of insertRule, I take a selector and a set of styles, and I always create a new CSS rule. The selector is always a string, right? It's just a CSS selector. But the styles can be either a string or an object. And what this really means is that your API should be flexible. Like, think of jQuery. jQuery in its public API, like the $sign parenthesis, there's like tons of things you can do. You can create an object, select something, and there's a whole array of different specialized selectors and whatnot. But the end result is always the same. You get the jQuery object back, right? And that's the idea behind this. So if you were to implement the insertRule thing, you'd have to parse these styles. If they are a string, you just use that. If not, you take the keys, you convert those keys to hyphen case, you pair them with the value with colons, and you chain everything together with semicolons, right? You get the same thing back. So that's the consistency part. Then you work your way through browser issues, and voila, you have a module. The other side of a high-quality module is extensive documentation. And this really means that even in that tiny piece of code, I have a public API that I need to document. I need to document how to install it, what it's named, and what it does. And if possible, I need to show an example of how to use that API and both ways of using that, possibly. The other thing that you probably want to do if you are writing documentation is maintaining a changelog. And eventually, changelogs are a great thing because eventually you'll get used to creating a new version every time you change something in your code. And that represents a problem, right? Because you'll end up having to create a new distribution and create a new tag on Git and publish into NPM again, and so on. It's kind of a hassle. So that's where automated builds come in. And that's something you should really, really be doing. So automate all the builds, right? So you'll need to create a new build distribution. And by that, I mean you'll have to compile your bundle again into something that people can grab and take to their browsers and have it work. Because it's not just the CommonJS version. Maybe someone who doesn't use CommonJS wants to use it, and that's okay too. Then you'll have to bump the package, both the package JSON and Bower JSON if you use that. You'll have to tag it on Git so that GitHub releases and Bower understands that you have a new release. And you'll also have to publish it to NPM. And you can do all of that with Gulp, which I'll show you now. So to use Gulp, you'll have to install it globally and locally in your project. And then you need to create a Gulp file, which is basically a list of tasks that Gulp can do on your behalf. So let's start with the build task. The build task looks like that. So I'm just using a generic library name, but kind of to show you the idea behind it. So you'll start by using the Browserify native API and using the source code for your library. You just need the entry point because everything else will be inferred by the required statements that you have. And you bundle everything together with a few options. The debug option will allow you to create a source map, and it'll even be inline in the bundle, so that when you open up the DevTools, you'll be able to see the stack traces pointing to the source code rather than to the bundle full of gibberish and whatnot, so that you'll be able to make sense of it. And then the standalone property allows you to create a UMD package, so that people that use AMD and etc. can use it. And it'll also be published on the window object if they don't use anything. Then you bring it back to gulp. You are able to add a little header maybe with license information, a link and the version number, and you write to disk because gulp does everything in memory. Then you can rename it, minify it, add another header, print the size to the console just for reference, and write to disk again. That's the basic idea of building the distribution file. Then there's development, right? During development, you don't want to be doing gulp build every time you change a file. So you'll write a watch task. This allows you to use a glowing pattern, which is basically going to map to every file in the source directory or any subdirectory that has the JS extension. So you watch for that pattern, and whenever a file change is detected, it will run this function, and then you are able to start the build again. The bump task. Here I typically use an environment variable so that I'm able to do like bump equals minor to change the minor version, and I default to patch. Semver usually has like major, minor, and patch. So I basically take in the package and the power JSON, I bump them, and write to disk. Really easy. Then there's the tagging on get. You create a commit message, you tag, you push, including the tags, that's it. Publish into npm. npm publish, you depend on the tag task because you usually do both together. And it's just spawn npm, passing in publish as an argument. I'll inherit the standard input so that I get in my terminal wherever the spawn process tells. And when that process finishes, my task is done. So really, you have two different flows for your application. You have the development flow, which is gulp watch, and you just continuously develop your application, and as code changes, your build will run again. And then you have the release flow, which will allow you to build, bump the versions, and release, and do all the nice stuff that you don't want to do ever by yourself. And the last thing I wanted to discuss is some use cases, so that you're able to kind of get an idea of the different ways in which you can use CommonJS for much good. And the first one is Poser. Poser is a library I developed to extend natives safely and easily. And basically by that I mean, how many times have you wished jQuery used the array prototype? Like you were able to do jQuery div for each, right? It's a very basic thing, yet it's not able to do it. So with Poser, you actually can implement your own jQuery that does that. And it's really easy. You just create an iframe and steal the array from the iframe. And that's another context, so you won't be messing with the array from the browser. You'll just take an array instance that nobody else is going to use ever, so you can base your library on that. But that's on the browser. You don't really have iframes in Node. So for Node, you'll have to use the VM module, which is a Node core module. And VM allows you to run code in another context too. And then you can say stolen equals array. And you'll use a sandbox. And when it runs, it'll put stolen in your sandbox because that's the global object. And voila, you stole array again. So the problem with that is that these are two different things, yet they do exactly the same. So if you're trying to develop a library that works seamlessly across Node and the browser, you can really have 2 different distributions and tell people, hey, use this if you're using Node, use that if you're in the browser. It gets really messy. So the solution to that is adding in the package.json file, you're able to declare main as the Node version and browser as the browser implementation. And when you use Browserify to compile that for the browser, Browserify will look at the package.json and figure out, hey, he wants to use this implementation for the browser, so I'll use that instead. And that mostly works, but what if your library just has the persistent.js implementation changing rather than the whole thing? In those cases, you are also able to use this form where you are able to say, okay, this file, this single file, I want it to be this implementation instead. So that way, I'll be able to change my file system JS to local storage JS. And that'll work as you expect it to. Another way to use CommonJS and Browserify is sharing stuff across your stack. And this only applies if you're using Node, of course. But in the case of Taunus, which is a shared MVC rendering module like Render, React, and a few others, what it does is it shares the view routing and the view templating functionalities between the server and the browser. In the client side, it will actually use the routes module, which is what Express uses for view routing, so you get the exact same route treatment in both sides of the stack. And for view templates, it just uses a function that takes in a model and returns an HTML string. So on the server side, when you try to get a view, like say author compose, if the headers accept HTML, then I'll render the full layout plus I'll render the partial, and I'll give you the whole thing so that Google is happy with it and it loads faster too. But if you're asking for JSON, I'll just give you the partial view model and you figure it out. So on the client side, on the first load, the browser will make a GET request. The server will say, oh, you want HTML, take the whole thing. And the client side will execute a controller that's specific for that view. But then, after navigation, clicks get hijacked, and you make an AJAX request instead of just navigating to that view. And that means that you'll get the JSON back, and you use the view template on the client side with the model that you just got, render that, and run the client-side controller again. So the cool part about this is that I'm using the same views and the same routes for both sides, and it's really, really simple if you look at it. And I'm still able to share the code and run the same code for both getting the model in the client side as well as on the server side. And I do this without making any extra requests or weird things like that. And in fact, in the client side, I'm using another layer of indirection, which is called Measly. And what it does is, if you route your AJAX requests through that, and they get, say, 400 status codes, which is bad request. Instead of handling that request myself, I'm able to handle it in a global level And that means that I'll say, okay, so this is a bad request. It's executed in the context of this DOM element. So I'll just print the messages from the bad request for that request. And what you get as a result is a stack that's really componentized and yet able to do anything that you'd expect from a more mature application. So, as a recap, we saw modularity in JavaScript and the different ways you could attain that, either by closures, ES6 modules, AMD, or CommonJS and Browserify. We saw how to design high-quality APIs and document them. We saw how to automate our builds in Gulp so that we don't spend a lot of time wasted. And we saw a few different use cases that you could hopefully be inspired by. So that's really all I have. Thanks.
Thank you for this talk. One thing that bothers me about doing JavaScript browser and server-side development is how do you make sure that, for example, security and access control is done right? Because if I change the modules, I tend to code ubiquitously on the server side as well on the browser side, on client side. And how do you try not to write every possible hacking method in the client?
Okay. So what you're saying is, how do I not validate on both sides? Yeah, but you can share the code with using Browserify. You could have your rules in a module that doesn't depend on either the server or client specifics. So you could have like a function that takes a model and validates that model and returns whether it succeeded or not. And then you could use it on both sides seamlessly without having to resort to copying the logic. Because if you're using like C# or Java or Rails or whatever, you are probably going to have to duplicate your model validation logic in JavaScript, right? But if you are using Node and Browserify, you are able to have it in an isolated module and load it from both sides of the request.
Okay, that one I understand. But how do you manage access control, for example? So I only return a certain number of rows from the database, and since I push the code to the client as well, the client can go and manipulate the data question.
Sure. Typically, what you do in that regard is, in the case of Taunus, for instance, I'm able to define middleware to run before requests. So, for instance, if your request is just for authors, like in the example, you can run a middleware before actually responding with anything, whether it's HTML or JSON, doesn't matter. And yeah, of course, you have to run validations in the client side, typically, because that usually improves UX. But you're also able to, if you're copying that logic in the server too, you wouldn't have any access control issues like that.
Thanks for the talk. At some point, I kind of lost the thread, and it was more about Gulp build system than Browserify.
Mm-hmm.
But the last problem you were talking about was probably the most interesting for me now. So that you try to make a unified view, or that you can serve the same code to the browser as to your server, and maybe doing other things with that code. So you mentioned that you deliver partials for the client from the server, or that you load partials from the server, and when the server gets hit with the request, you're going to render all these partials together and deliver the whole HTML.
Okay, now basically how it works in Taunus, you have when you bundle everything together with Browserify, you will get all of your routes and your partials in like the function model partial as part of the bundle.
What do you mean express routes? Or what routes?
Yeah.
Express routes.
Yeah.
Oh, okay.
But in the client side. Routes is a tiny module, so you just have the route rules and which controllers they match. So once you have downloaded the application, the nice thing is that on the first load, it will just go through the server. So you'll get the full thing rendered, and then the JavaScript hits, and it loads the client-side controller for that. The next request will be JSON, so it will just get the model for the partial and use the template that's already on the client side to render it. And then it will run the controller that's also on the client.
But that's when you Browserify Express, or?
No.
No?
No, Browserify is just for
creating the client library, right?
Yeah, for your client-side bundle. What you use on both the server and the client is called Taunus, which is the library I developed. And that's kind of, instead of defining your routes directly on Express, you basically define an array with the URL or the regex for the route, the controller, and any middleware that you want. And then that is used by Taunus to create the client-side route and to talk to Express and say, hey, I want this route, and this route.
Okay.
You know.
Now I get it.
Okay.
Thanks.
So in Browserify, you basically create bundles that contains all your libraries in one JavaScript file, right?
Yeah.
So if you want to create, say, 2 bundles, how can you asynchronously load the second one with Browserify?
Okay. I've never done it, but as far as I know, there's this concept of external bundles. So basically what that means is that you tell Browserify as you are compiling something that it should just hope that whatever is in the other bundle is actually there. So what you do is you bundle everything, like your vendor stuff, like jQuery and whatnot, into one bundle. And you load that first, and the specific smaller bundles are loaded after that, asynchronously if you want. And they just hope that the other stuff is already there.
Okay. Maybe we can use require.js for that.
Oh god.
It's a full circle.
Yeah. And throw in ES6 while you're at it.
Yeah.
You showed some example how to extract documentation out of the code. Is it like this Java approach where you put special markup in the code and then it's get extracted? Or I just saw for creating the change log, how did you do this? Because this
the change log.
And how did you document the code? Because you mentioned it's important, and I like it too if there's some notes in the code.
Okay, there are two different things. I just write them by hand. Once you get used to it, it's really easy to maintain a changelog by hand. And in my experience, it's usually better because you can definitely tell if a changelog is generated through the commit messages. And typically, they end up being completely meaningless because you end up with commit messages that even if you edit out those that don't make any sense, like git commit foo, you're still going to be talking about specific changes in the code rather than public API changes that actually affect users. So my advice would be maintain them by hand.
I was just wondering why to use gulp instead of grunt, because I recently had to do pretty much something similar with grunt. So I was just wondering what's advantages and disadvantages between them two.
Okay. I have an entire other talk for that, but in short summary, I would say, in my experience at least, npm run for my own stuff that nobody else ever touches, because it's kind of personal. Gulp, I typically recommend for projects that are actually written in Node, because it's probably harder for people who aren't in the Node community to figure out streams and asynchronous code and etc. And Grunt for everything else, really, for large teams of people who have no idea what they're doing and they like Windows. No, but really, Grunt is great for PHP developers or people who aren't closely tied to JavaScript, you know. But whatever you like, you should use, and if it fits your needs, that's great. You don't really have to choose, especially in build tooling where there are just so many options. There isn't really a best one, you know, like Grunt, Gulp, Broccoli, wherever. Use what fits your needs.
Thank you, Nicolas.